In this lesson we're going to look at a hard example from the Heinemann textbook on page 215, question 15. So there's quite a lot to this question, 3 parts, and a lot of good knowledge that you can use in other different types of questions. You can use the same techniques that apply here. So we're told that circle A has equation x squared plus y squared, take away 10x, take away 12y plus 36 equals 0. And circle B has equation x squared plus y squared plus 8x plus 12y, take away 48 equals 0. Find the centre and radius of each circle. So we'll do that first, it should be quite easy. Using our formula sheet here, 2g is the coefficient of x, 2f is the coefficient of y, and the centre is negative g, and so on, just using this. So the first equation, you're going to get 2g equals negative 10 and 2f equals negative 12 and c is 36. That means g is negative 5, f is negative 6. Centre is negative g, negative f, so it's going to be 5, 6. The radius is g squared plus f squared minus c, and square root it from the formula sheet. So putting in your values, negative 5 squared plus negative 6 squared, take away 36. 25, add 36, take away 36, we're going to end up with square root of 25, which is 5. With the second equation, 2g is 8, 2f is 12, and c is negative 48. Same idea for the radius. So g is equal to 4 and 6 for f, negative 4, negative 6 for the centre. We're going to have 4 squared plus 6 squared, subtract negative 48, be careful with that, some people miss it. So 16 plus 36, add 48 now, and that comes to the square root of 100, which is 10. So that's the first bit solved with not much hassle really. So let's go back to the top and see what the next bit. Show that the circles touch externally. Now to show this, it's good to look at this diagram here. Now to show that they touch externally really means that you're looking for this diagram here. Now to do this, what we need to do is compare the distance between the centre points to the two radii or radiuses added together. If radius 1 plus radius 2 is exactly the same as the distance between the centres, then they'll touch externally at one point only. If when you add the two radiuses together and it comes to more than the distance between the two centre points, then they intersect twice. So finally, if you add the two radiuses together and it's not as much as the distance between A and B, then they don't touch at all. They're the three kind of main criteria here. And it takes a wee bit of common sense to try and think it through. So we have to use the distance formula once we've got the two centres, and then you just add the radiuses together. So our radiuses come to 15, so if we use the distance formula to find the distance between these centre points, 5, 6 and negative 4, negative 6, and it comes to 15, then the circles touch once externally. So the distance formula is just Pythagoras really. You subtract the x coordinates, square them, subtract the y coordinates, square them, add that together and square root it. So that's going to end up looking like this. Subtract the x coordinates and you'll square them, then you add, because it's always a hypotenuse you're finding between, if you think about the 2 points, then that's the hypotenuse when you create a right angle triangle. And you subtract the y coordinates, the 6 and the negative 6, square them and square root them. So 5 take away negative 4, that's going to be 9, and then 6 take away negative 6 is 12. So that's going to come to square root of 225, which is 15. Okay, restatement. Since AB is equal to radius A plus radius B, the circles touch at one point. Right, last part of this question, find the coordinates of the point of contact. So the best thing to do is a wee sketch for this again. You've got the point 5, 6, which is the centre of the first circle, and then you've got negative 4, negative 6, which is the centre of the second circle. So this is really looking like this, if you like. This is what this means. And the radius of that was 5, and the radius of that was 10. That's what you were doing there, and we were trying to work out this coordinate here. So I'll get rid of these circles. What we need to think of is moving along the coordinate grid, along and up to get to here. Now if you think of ratio, then this yellow circle is 10 over 15. It's 10 along and over 15 altogether, which comes down to, simplifies down to 2/3. 10 over 15 is 2/3 along the length of this. So if we turn our attention to the bigger triangle, like this, and we think to get the x value of C, you go 2/3 along this length. Now this length here goes from negative 4 all the way up to 5, so that length there is 9. Just mark that in. And if we look at the y values, that goes from negative 6 to positive 6, so up and down the way is 12. So we're trying to get 2/3 along and 2/3 up to get to the point C. So 2/3 of 9 is 6. So that journey is going to be 6 along. And 2/3 of 12, if you did 12 divided by 3, you get 4, and you double that, you get 8. So that's going to be 8 up. So if we're at negative 4, negative 6, we go along 6 places, so the x coordinate is going to be 2, and then you go up 8 places from negative 6, and that's also going to be 2. So from B to A is 9 along and 12 up, so from B to C is 6 along and 8 up, I've just shown that, so C is 2, 2.